Hello and good evening to our last MAMUZ talk. Today we are talking about cat heads. Don't worry, it's not a video about pets. No, it's about experimental studies based on ancient Egyptian casting molds. Therefore, I'd like to introduce our experts, Georges Verly. Bonsoir, Georges.
Bonsoir.
And of course, our head of science, Franz Pieler. Hello, Franz.
Hello.
Today, we talk about this topic. And of course, you also have the chance to ask questions. Therefore, you can write us MAMUZ online at mamuz.at. You can also write on our YouTube chat and on our WhatsApp number. You can find the telephone number on our homepage or on the information of YouTube. Yeah, so I'd like to give the word to Franz. Maybe we can start now.
Yeah, thank you very much. Yeah, good evening. Welcome to our YouTube channel. Today we have a talk about casting cats' heads, which is a quite exotic thing as far as I'm concerned. I mean, I like cats, and I have two at home actually, but I never got the idea of casting cats' heads. But I guess there's an idea behind that. So my partner tonight to this evening is Georges Verly. And what is your biography? How did you get to come to do archaeology, and how did you go to get to do these casting experiments?
Mm-hmm. First, I would like to thank you and to thank the whole MAMUZ team. Is really kind and really professional. So thanks a lot. And I apologize for my so petty English. So I would like to say that, okay, I start. My teacher asked me to work on a tabentum and on a metallurgical taben sense. And when I try to understand the scene, I understand that I don't understand anything. It's really complicated. So I would like to find something new, because archaeology is really nice and I'm just an archaeologist, but I would like to have a better understanding. And when I read the book, I understand that nobody understands the scene also. So I go to a master in bronze, Paris, and I start to learn all techniques with him. And after years, I try to write the first methodology in experimental archaeology, and to create a scientific tool for archaeology and to understand this. And I like a lot when you have theory, when you have practical part inside, when you have manual things to do, and when you can make a combination, a smart combination between the all disciplines and interdisciplinary. So it's really great. It's like a credo, and I like this kind of method.
So, sorry, forgive me, I didn't quite get it. Where did you study then? It was in Belgium.
It's in Belgium. It's Université Libre de Bruxelles. So I do classical archaeology.
Right. I was about to ask, did you do classical or prehistory?
The classical studies. So in antiquity.
Okay. All right. Yeah, well, you know, in Vienna, it's the experimental archaeology would be traditionally connected to prehistory rather than the classical archaeology. But it's very interesting to talk to somebody who did this from the classical archaeology part.
This is something that is not at the beginning not proposed at the university. Is by myself. It's just because I would like to understand more, and I like to go to the end of the point and to understand very well when I try to say some things. And so I do that by myself. And after years, my master, my teacher asked me to come back to the university and propose also this methodology for the students. But I make just classical studies, and I would like absolutely thanks Paris for this. Is my master in bronze, and he do a really great job in this.
Thank you. So, you know, well, experimental archaeology is always kind of cooperation between academics and artisans. And so you kind of have the both of two worlds in yourself, in your person, kind of. So you studied and you did the artistic part as well.
I think it's for me, it's not artistic. It's more to explore the sense. It's more to say you have a body, and your body must to be in contact with the reality. Reality is, of course, first the digging is the archaeological site. That's the main point for us. But also when you are close from the fire, when you need to use the tools, when you need to see how a fire works, how to reach the temperature with the ventilation. So you can also use your body so like a real tools and exert your ears, your eyes, and try to do this in the same condition. That's really important, because that's why I say that is new question that you can bring in your site. When you are close from the fire, you need to say, okay, I work with 1,200 degrees. How to do that without any clothes, without any new protection? And I think that's what is interesting is that you can, thanks to the ethnography and the experimentation, you can just add new question in your site and try to find the answer.
Sorry, excuse me, sure, just to interrupt you. Gerald, your screen is still turned on. So it might be a bit irritating for our visitors. Thank you very much. So sorry to interrupt you.
No problem.
Yeah.
So it's only this. It's just to make new tools, and I think that's archaeologist is a tool, and your body is a tool, and so you exert the maximum as possible. And I think that for me, the experimentation is you need to define the word. That's why I say that's I try to make a scientific tool. That's why I say that I use only one methodology based on strict protocols, and I have protocols from each case study. But the case study come always time from the site himself. So you need to have a site. You need to do by yourself the excavation. Then, of course, you have just remains. So you are full of questions.
Yeah.
And you can open the question to the all disciplines, but one of them is the experimental, but you have also analyzed with many things. So like this. And the goal, the only goal for me from experimentation is just to be a better archaeologist. It's only this, not for the rest.
Yeah, of course, it's no self-purpose. I mean, it has to serve some higher goal if you want. Yeah, of course. Yeah. But so your experiment to get to the core of our talk today was with casting the cat's heads. That was your contribution to the Experimental Archaeology World Tour and to our exhibition in Aspern. So what was the archaeological evidence that was, you know, the foundation for this experiment?
Oh yeah. So the foundation come from a very human good story. That's what I say. That's the starting point doesn't come from me. I would like absolutely to thank other people. I would like to thank Martin Fitzgerald, Frank Wheeler, and Johannes Hannemüller, because they make the job first. And what is really nice is that they share information. We can make a collaboration. We still continue the collaboration, and it's the first time that different teams in the world can have the same material at the beginning and go together to understand this material. So thanks a lot from the collaboration and for the all data that they gave. So that come from here. That come from Kubetelawa. Kubetelawa is a site from Aswan, and in the tomb they find many normal things, so like sarcophages or so like this, but they find also. They find also this, and this, what is it? Is mold. That doesn't have any shape. It's not really interesting at the beginning, to be honest. But I think it's one of the most important things in the antique technology that we have in the world for this moment, because they are complete. You have different phases inside the law. And so that's why I say that you can understand the dewaxing, drying, loss wash techniques, the chaîne opératoire with this. And it's really, really interesting. So they propose a first book, this one, you can see, that's full of studies, really nice. And you have a small paper here in this one. So if you like, you can continue the study with this. So first, what they do is, of course, not to break the material because they are unique and complete. So that's not so good. So with Meinl and Wheeler, they make micro CT scan, and you can see that inside, that is just radiography, but with the micro CT scan, you can see some really interesting things. You can see that you have different layers inside, and for each mold is the same things. And you have always the same layer in the mold. So one of in the methodology that we create, we would like absolutely to speak about theology. Theology is the purpose why you use a layer, why you use a furnaces, why you use the structure of this quality of material.
To apply certain technique.
It's really technical, part. And we see that first they create the wax. Then you have a tiny layers. That's the defined layers. It's really complicated to create this one because if you have a crack inside the layer, you have a false castings. So it is really important to have a good material for this. Then you can see that you have another one. The second one is the vent system. And that is directly interesting because if you know a modern casting, you know that you have a casting sprue. You have then the statue, and then you have the stick to permit to the gas to go out from the mold.
Of course, That's how we used to learn it,
It's the first thing that's visible. And you say, but how they do that? Of course, the gas must go out. But
of course, it would explode otherwise.
They find the trick to make one of the best of the job. Is you don't have any contact between the vent system and the wax directly because you have the quality, the defined layer here. But still, the gas can go through the layers, and it's a kind of long that you have here. But we must to prove this one thanks to the experimentation. But this is the main idea. And then you have different layers, not important, but you have the structure layer to reinforce everything. So the thing is the protocol that we create different protocol to understand the first and the second layer, essentially, and to see the theology of this one. And if the chaîne opératoire that we propose, of course, is just a theory, but if it's possible or not possible. So we do, that's the reason why we do so much mold and so much casting, around 150. So it's a lot of them. But at the end, we find theoretical proposition to create maybe a theoretical chaîne opératoire. But we find really good things for this. I don't know if you like to see the video to explain this one.
Yes, please. Yeah. It would be lovely to see that.
Okay. I can maybe show you this one. So that's the collaboration that we do still together, still in this moment with Johannes and Müller and the Bonn Museum. So you create first the core in clay, then you put the wax on the core, so like here, and you create the form that you want. That's not important.
What the result is then a hollow bronze figure.
Is this? It's more complicated than the Osiris production. Then you put the definition layer, and for this one you need to have fermentation of layer during 3 months, and a special humidity. If you have too much water, that doesn't work. If you have less water, that doesn't work. So you put directly the cat in the stuff, and you can see that after the drying, you don't have any crack. That's really important. And the problem, of course, comes from the clay itself. You know that when you have a clay, when they dry, you have a reduction of the volume.
Of course, it would crack naturally,
Okay, in this case, it's not. Because we use the fermentation, we use the juice of the donkey donk, and we use a special silt, the tiny silt as possible.
All right.
And when you have the good hydration, After this, but we take years to understand that. But after this, you can have a good result.
Yeah. And how long does it take to prepare this fermented clay?
3 months.
Wow. Wow. Okay.
And you need to degas every time to come back to the layers and to see. It's not a huge work. It's just inside the protocol. You need to have time to do it. It's only this.
Yeah.
Then on a dry surface, it's really important because you don't put like this only 1 millimeter. If you put water on it, you lose.
It's gone. Yeah.
So you can put the second layer is the vent system. So this one is full of donkey donk, not juice, but the real donkey donk inside. So the temper is the all vegetable that you have inside. The remains of vegetable inside is full of them, and that creates the future network. The future network long inside the layer himself.
Okay.
So you put around 1 centimeter of this paste. And you need just to be focused that you have the same thick of layer around this. It's not complicated.
Yeah.
When it's finished, you would like to put the casting funnel. So they create a part. First, you see the pouring cup here.
Yeah.
It's created before that we see very well in thanks to the micro CT scan. Yeah. And you put the ring system. The ring system is just to make a connection between the cup and the rest. So you see very well that you don't have any vent stick outside. Everything is close. We make the junction between the poles.
And the wires are just to stabilize the clay mold, or?
Yeah, what you see there is just for the core. Because the core need to be in the same way that you have at the beginning. If they move during the casting, of course, you lose the statue. So it's in 3 dimensions that you have the stick, and it's just to help the core to not move during the casting.
I see.
Okay, so it's absolutely not for the vent system. It's just
no. I didn't suspect that, but
it's not this. No, I'm sorry.
Yeah.
So after you just have to put the last layer, it's just a structural layer, really sandy. I must to say something is really incredible, is that they think about the structural layer, so like a reinforcement, of course. But what is just amazing is that after the casting, this layer have another function. This layer must be the most breakable as possible. And that's the reason why you have so much sand inside. It's just because if you have too hard layers after the casting, you can create a shock on the bronze and break the bronze. So during the whole process, the function of the layer can be variable. You can first have a structural layer really, really hard, and after the process, it must be really breakable. So this really nice. They are really smart.
Wow.
And it's something that also is quite interesting in the process, is to see how many tricks that they find with just silt and donkey donk, but they find they can create the job. That's nice.
Yeah,
so
indeed,
for the waxing,
fascinating.
Yeah, that's nice what they do. Really, they are smart. They are really brilliant. After this, we use a furnaces. This one is an hypothesis, come from Kerma at the beginning, but also from other sites like Cantier. We need more works on it, to be honest. It's a proposition, but what is really nice is that we can use this fireplace and we can control the fire, because you need step inside during the system. That's why I said at first, you see that the molds is reverse, so the maximum of the wax can go out.
Can fall out,
And because the layer is dry, so they suck also the wax. So that's not good. So you try first to keep out the maximum of the wax. Then the wax, of course, burn himself. And you go to 600 degrees during 2 hours. Just to be sure that you don't have any remains of wax inside. If you have remains, you have an explosion of you fails the casting, so it's not good. But what you are sure is that is an oxide atmosphere always time, because when you look the antique mold, you don't have any remains of reduction in the clay. So it's also a good thing to see is which kind of atmosphere is the fireplace, and it's always an oxidized fireplace.
All right.
So after this, you can open the mold. You see that they are really reddish. So like we have in antiquity.
Okay.
And it's quite hard. It's not really a ceramic because it's only 600 degrees.
Yeah, but still it's hard enough, obviously.
Hard enough to make the job. Yeah. This one is a modern casting, so that doesn't have any sense. It's just a modern things because it's too complicated to have everything in the same protocol. It's not the main goal for this moment.
Yeah, sure.
So you see that I cast only with a stick of wood, and I just put some mud on me for the protection. It's large enough. And I made a casting directly in the sand. And so you can see the casting of the mold in the sand. Once it's finished, you need to break the mold, of course. You see what you have inside. And and what is really nice for us is not, of course, made the cut is important because you reach the goal of it. But what is more important for us is this, is to have the same comportment and to find this tiny piece of mold, because in archaeology, what I find is this one is not the cat.
Yeah, of course. So, the cats would have been used somewhere else. Yeah, of course. But you see very well the different layers of the mold here. Yeah.
So you see the different layers, and also when we would like to make a validation, because you need a validation for your protocol, and the real data is the excavation data. So when I compare now the excavation data, and when I see the different layers during the process, so when it's dry, when it's dewaxed, and when it's cast, always time we can make a validation. And here you see very well that the vent layer is is not reddish, so like the external one, but it's blackish, because the gas go inside the lung and inside this one. So the hypothesis is good, and we can make a validation with the archaeological data. And now what we are doing is to continue the analysis with Johannes Müller and my colleague Frederik Rademakers. And we make 10 sections about the clay. We make also analyze from the wax himself in the museum and on the bone mold. So we continue now the process to understand and to go faster as possible for this. So that's this. And
absolutely interesting and extremely well designed, the experiment. I admired it when I first saw it in the exhibition last spring. Really, it's wonderful. And you talked about that you had it. You applied it for some further thesis.
You would like to, if I understand well, you would like, I don't understand now. I'm sorry.
No.
What is your question? I'm sorry.
No. You mentioned earlier on that the results of the experiment gave you clues for some other theories.
It's the first time I would like to say that we are really happy about that, because you have the first production, but also when you try to understand ancient technology, of course, you know also what is possible normally and what is not possible. And one of the things that we know normally, when you cast a bronze and you would like to recast another part of the bronze, it's not possible to make welds between the both. In antiquity, we don't see any weld. And so it's something that comes from science. And so we are really surprised, because in the production, we have a new production, is the B production. I'm not really original, but that's the B production. And what's the Bonn Museum and what Johannes and Martin find is something really, really strange. You can see here this one, but this one is more clear for us. So you have the mold, but inside the mold, you see that you have bronze feet, and the rest of the body is in wax.
Wow.
And this one is not normal, absolutely not normal.
No, that's not normal, definitely not.
No, if you know bronze, you say it's not stupid, but it's something that you must say, okay, why do you do that? It's so complex. You don't have any good result. It's impossible to have a weld. So we don't understand. And we would like to continue to understand this one. And so we go to the Frankfurt Museum, and we see that we have some exemplaries where the feet is just broke. And sometimes you have new feet directly linked with the body, with the rest of the body. It's a false weld. That's what it's not really. When you have in your hand, you see that you have something. It's not really link, but you have a technical link between, and it's very special. But you have more special, because inside this production, Johannes finds something really new. So you have, of course, the 4 Osiris, 3 with the bronze feet and the wax body. But this one looks complete, but it's not complete. It's break in 3 parts. And inside you have an iron stick inside. And if you look inside the micro CT scan, you see that you have a wax stick, and this wax stick stop on the feet and stop on the head where it's break.
So they use the casting to stabilize the fragments.
And if you go back now to the museum, you can see in the Frankfurt Museum that we have scarf weld on some of the Osiris. And so that's the first time that, thanks to the experimentation, we can propose something totally new. Because if you know the normal techniques, you can identify in this case that is absolutely not normal. It's a lot of work, it's complicated. It's in mass production. You must know that in some of the temples in Egypt at this time, you have thousands of Osiris like this one complete. Why they do that? Why is so complicated to do that? So we propose for this for this time something totally new. It's a new rite, and that would like say that if you look really know, if you look the collection and if you look the Osiris. You have so much that's impossible normally to do that. And you see that some of them are special. So like eating, but you don't know why. No, we know that they do a hot break. They conserve only the feet. Why? Because we are in Elephantine, and Elephantine is a temple where the feet of Osiris is conserved. If you know the myth of Osiris, of course. And that makes sense in this case. And from the feet, each year, the Nile come inside the land to give the fertility for the field and to bring back the life every year.
This is a kind.
So that's really interesting to make now a link between technology and the reality of the antique state and the antique mentalities. That will I say that if you make the experimentation in this way, in the same context, of course you produce an Osiris, but without any contact, that's not possible, but it's not important. What they would ask in the past, the official asked to the craftsman, so like a facilitator, I would like to have a new kind of object for my rite, and it's a new rite from the 26th dynasty. So what I would like is the figure of Osiris without any cast system. Of course, you break this part. It looks complete, but you don't need to know how to break with the fire. You just would like to have a new statue. So you can take it in your hand. You can break with your hand. It's really
it's very easy
to do. And after this, with a glue, so like the beeswax, you can create the life, because you can say, look at me. I put the body and I complete the form of Osiris. So I give the life to Osiris. And that's a new support for this. We know a lot of support for this rite, but this one, especially for the 26th dynasty, close from Elephantine, we know that we have something totally new and that nobody know for this moment. It's a very new things in Egyptology.
Wow, I've never heard about this before. Well, it's fascinating. So it's kind of they were kind of casting figurines with broken parts, and they were kind of ritually completed and glued together for some ceremonies only.
Is this? So we proposed a paper, the IFAO, and the IFAO accept the paper. Is under publication for this moment. And I think that's open a new field in the retail system.
Wow. Wow.
So
Extremely interesting. Yeah.
it's something new that's thanks to the experimentation, because with this, of course, you'd be a better archaeologist, but also you know where is the limit. And in this limit, you see that is something strange, not usual. And you say, why they do that? Why so many effort to do that? If you know that it's easy to make just a new Osiris in this case.
Of course, yeah, that's what we naturally would think, that, well, it's broken, why they just recast it and have a complete one. Yeah.
So yeah, it's totally something new. And we, I would like, of course, also thanks the Overschi, the site of Overschi, for the place where I do, but we do that also in Mel. So,
yeah, you've been talking about Mel. That's an interesting place you have there.
Yeah. Mel is the other place where it's possible to share information, and also possible to work with other teams. And I would like absolutely to thanks Florian Terejol, the boss from the site, Jean-Philippe Marnet, François Perrat, and Jean-Charles Méaudre. It's also a really nice team, and you can share a lot of information. It's a really good site for this. And in this case, we work on something quite different from this moment, because we try to understand the melting, the smelting, the mining, the lost was techniques. But sometimes you have something quite strange. Is another strange case study. This one is you are not in Egypt, you are in Sudan.
That's so far south now.
Yeah, it's another excavation site, and the name is Kerma. And Kerma is also with the team. They are really kind, and I would like absolutely thanks also Séverine Marchi and Charles Bonnet. They make a really good job there. It's really fantastic. And what they find is that close from the Defufa on the site on the ring in this place, they find at the some years ago they find this structure, and this quite strange structure is something really long and large. It's really something new.
Furnace. So what is it? You think it's a type of furnace?
The first theory is to say this is a bronze melting furnaces.
Okay.
And we would like to understand this furnace, so we ask an authorization to go to the site, and shall give the authorization. That's really nice. And we make new excavation 2 years ago, and so we would like to understand this one. And the first hypothesis is to say, okay, we speak in metal technology, we speak all the time about smelting and melting, but nobody speak about the Oswas techniques, nobody speak about the mold, but nobody speak about the furnaces that you need.
Yeah, that's a bit out of the obvious.
And so I say to Charles, maybe it's a dewaxing furnaces, so like it's also possible in Cantir. And we go there with this idea, and thanks, that's my colleague, Frédéric Rademacros, and I would like to also thanks my colleague, he's a good one. And he make analyze on the site directly. And when we make analyze, what we understand is that you have remains of bronze everywhere, not on small parts, but the surface here is full of remains of bronze. That's the first thing. The second thing is that here you have the casting sprue, you have 4 casting sprue here, and you have the remains of a door on the front here. So this is very special. So on the side directly, thanks to the analyze and thanks to the collaboration with Frederick, we understand that is something different. Absolutely not possible to have a dewaxing furnaces. Maybe that's the first step for a future dewaxing furnaces, but in any case, it's not this. So we would like to understand that. And what we propose is that you have 4 fireplace, huge one here and small one there. You have a dome here, but thanks to the 4 casting sprue, we know that here you have a mold, a very, very large mold, a flat mold. That's what I say, that maybe it's the first furnaces in the world to create plate of metal. Is the most complicated technology that we know. And you need to know that we are 2000 before Common Era. So it's really early technology. And is not copper, is already bronze, because we have arsenic, tin, and copper in the remains. So it's really exciting. And on the side of Mel, it's a very good side because you can do what you want in science. So you can create grid structures. So like this one, it's a part. It's not the complete form because it's impossible with the money, but it's a half part from the furnaces himself. So it's the first one is a test before the excavation for the methodology, and this one is after the first excavation, and it's totally different. So we try to understand how they manage the fire inside, and we can have at the end a good idea about the temperature. The maximum is 500 degrees on the mold. And when you create a sandy mold, but only with sand, not with clay, it's impossible. You can pour the bronze inside the casting sprue, create a huge plate inside, and you can make it the job. So it's the first starting point for this moment. Of course, we don't have the whole answer for the question. With more question for this moment than answer. But it's really good. And Séverine come on the site many times to see the job. And we would like now to do this, the real scale on Kerma in Sudan. We would like to make a new project there. To work with the good quality of material, to work with the whole team there, and to try to create not a small plate, but a big plate. So shall see it's possible.
All right. So they were casting plates of bronze. What size are they?
It's like 1.5 meters per 1 meter.
Wow.
So that's
pretty big. Do you have any idea what they use them for?
So the theory for this moment, that's a comparative we can hear, but the theory is that we know that they use some plate, but not the large one, it's impossible, but some small plate to create a decoration. So with a chisel, they cut the figure inside the plates, and they use the figure to decorate the bed, the wood bed, for example. But we have, of course, other theory. One of them is the door that you have for the Temple of Ammon for the during the Ramses II king. This is one theory, but we are not sure. It's more late. Of course, if you go back to the site, the furnace is closed from the main door of the temple there. So it's possible that they create a plate here and put the plate on wood door. And the axe of this one is the west. So when you have the sun on the end of the day, it's in the good direction to have the good reflection.
The evening sun,
That's possible. The last possibilities, but we don't have any remains that come also from Egypt, is of course the possibility to create the statue. Because when you see the body, this part is Loswas techniques, but the rest is just plates. And with an hammer, you can create a shape on a wood form first, and you can create statue. We don't have this one. We don't have this one. We have just this one, but we have 3 possibilities for the use for this one.
All right, I see. Well, that's very interesting. I mean, I see on this picture left corner, there is a person carrying an oxide ingot. So they can't be used for ingots.
This is a really good question. You know, in Egyptology, the main problem is to know where come from the bronze and the copper. So that's most the work from Frederick Rademakers. What we try for this moment is to find the origin of the mines, and so we make a lot of analysis in the Museum of Brussels. We make paper about the Old Kingdom and Middle Kingdom, and we are focused on the New Kingdom for this moment. You need to know that this one is New Kingdom and the rest of technology is Middle Kingdom. So that's not the same period. But in any case, Frederick understands very well that in the New Kingdom, the system is quite different that you have for the Old and Middle Kingdom. Old and Middle Kingdom that come from Sinai, and is the research that I do for this moment with Pierre Tallet and Claire Somaglio from the Sorbonne University. I would like also to thank this person because they are really nice and they permit to make new excavation. So this really good team, and Pierre find a totally new system, an economic system in Egypt, and find a new papyrus from the construction of the pyramid. So they are also really nice in the job. So thank you very much. And if you work in Ensona, you can understand the metallurgy for the Middle Kingdom, and you know that the ore comes from the Sinai. In the New Kingdom, of course, is quite different because
they expanded further north.
Yeah, they come from there, and so Fred see that in the crucible from Cantir, so is the same period. He know that you have lead isotope from the copper oxide, and they come from Cyprus. So there are more possibility to have a more trade at this period. That doesn't really say that they don't go back to Timna in Sinai. It's just they have more opportunity to have more copper because they need also more copper at this moment. And so it's something else. And if you have the old sand, there's the Theban 100. And you see at the end that you have also the tin lead. The tin ingot. So of course, it's a schema. You know, in Egyptology, the problem if you read the same directly, so like that is impossible. I think that's one of the main things that we find is that in this case, it's impossible to make a link between the image and the reality, because if you look in Cantir, the phronesis is totally not the same shape. They make a simplification to understand what they do, but it's not reality. So that's
of course.
And it's also one of the goals of experimentation is to see the difference between iconography,
the representation and the real thing, of course. Sure.
So I don't know if I have this one. I have complete. So if you look at this one, this part, for example, is just a section of the real furnace. The furnace is 10 meters long. In this part, you think this roundish furnace is not the case. So here you have the tin ingot, the copper ingot, the master, the charcoal, and this one is
they're casting a door there.
The casting a door, but I think it's quite the same that we have in Kerma. It's not a mold. Absolutely not. I think it also is a representation of something, a flat mold, a furnace flat mold, so like we have in Kerma. So it's something totally new for this moment. We are just focused on it, but we think that, so like this one, that's not reality. It's impossible to make so huge door in bronze just for the weight. It's just impossible. But what is the solution is maybe, so like in Kerma, with a plate, and then put the plate on.
They would be fixed to the wooden structure.
Isn't this?
That's reasonable.
So this is the idea for this moment.
Fascinating, absolutely fascinating. Thank you very much indeed for sharing this with us and giving insight into current research on this really interesting thing.
Thanks a lot. But just is a real teamwork. So I must do it.
Well, most of it would be teamwork, of course, but you know, you have to have the idea and you know, be organized enough to carry it out.
We try.
Sure.
So I can.
Right. So this is one of the projects you would do in Mel. And it is an experimentation platform, as far as I understand. And is it connected to the university, or would it be an independent institution?
No, it's linked with the one of the huge laboratory that you have in France. Florent Terejol is one of the boss of the laboratory, and c'est le CEA, and so is really linked with the university, is linked with the PhD, is linked with the laboratories, and they make a lot of analysis and excavation themselves. So it's not a place where you have demonstration. Absolutely not. It's a mines. It's a very old. It's a middle-aged mines for the silver. But what is really nice is that during 3 weeks per year, the all researchers go there, create the furnace that they would like to do. They will bring the stuff there, and so you are free to make what you want, of course, in collaboration with the team.
Yeah, of course, yes, yeah,
of course. And at the end, you have many experimentation and many periods, because me, I work in Egypt, the other people work on France, Middle Age. Some of them work from Asia, others. You have different land, different periods.
Okay.
And the technology is you have the potter technology, metallurgy, of course. Okay. You have also the glass there. So
all right.
Yeah, this is really nice, and it's a good place for the fireworks. We can say that.
Yeah.
And the leader, when you propose the project to the leader, to Florian, you have a discussion. But after this, you have the possibility, of course, in collaboration, to do something and to propose new thing to do there.
Okay.
And,
Well, so it's kind of an open air laboratory then, rather than a museum.
Yeah, is this totally right? That's the main purpose. So of course you can visit the mine and you can continue the visit, but after this, the public can see what the researcher does there, and it's an open space where you construct your furnaces if you like. You can conserve also construction years after years. That's really important, and it's really an open space. And in the modern time,
Wow. And would there be a kind of a fixed time when these 3 weeks take place, or is it always the same time of the year?
Yeah, it's always time in June. It's end of the June and beginning of July.
All right.
So we know that each year we know that in this scale is in this timing.
Okay. Yeah.
Of course, Innovation is quite different, because that's the other place where I work, and this one is each week. We work Sunday there, so this is quite different. It's a place also where it's possible to conserve the furnaces. I have also a workshop there. Sometimes I work weeks there. That depends a little from the job. So it's really useful.
Indeed, yeah, I think so. Yeah.
That depends from the job what you want to do. I think that one of the good things in Obeshi is that you do what you want during the year. But in MEL, what is nice is that you have other colleagues, so you can share information, ask also a lot, and they always time. I must say that, so like the German team, the French team also share a lot of information, and that's really nice for the researcher. You are not alone, so you can ask many tricks of many things. Also analyze and interpretation, and they are really open mind for this, and that's really important for the research. That's really
And what I especially like is that, or admire, that you have the possibility to do these on a regular basis. Like you do this every week. So it's basically the routine that gives that results in very good results then.
It's what I said at the beginning. I think that the body is a tool, and you need to at the end to try to do the jobs like they do. So when I have the evidence in Egypt, in Ensuna, that you are in the desert, you just have your body. They have very few tools, so like wood stick of stone hammer, but not more. That's why I say that the rest is managed thanks to your body. So what I try to do is the maximum of experimentation that take times. So like 4 or 5 years per furnaces. But after these many years, I don't have a solution, but I can propose a chaîne opératoire. It's just a theory, of course, but it's the maximum that what I can do, and I make the validation, and so I hope that I give some good idea. I hope so. But
well, at least for my ears, it sounded very convincing and very impressive by all means. And well, what is certain in archaeology? I mean, we always were going with models and theories, so nobody was there actually. Nobody of us. No,
we are just learning.
We are
just learning. We learn.
Learning, of course, yes.
We are students,
and kind of trying to get there. Indeed. Indeed.
That's true. So, but of course, so like you say, more you have the possibility to do something and to repeat the tests. more is possible to be close on what you think about the reality. We can say that, if we can say that. Of course, it's really helpful. And I think that's one of the best opportunity of experimentation is, I repeat myself, but is to be maybe a better archaeologist and also to bring on the field new question. The question starts from the field himself, but of course, at one moment, thanks to the protocol, you can have an iterative interaction.
Indeed,
and so you can say, okay, maybe I can think about that. So I can make a new protocol. Thanks to the analyze, you have new ID, then you have new also question. And so always time you are in interaction. And it's also why it's so important to be in a team, because I think
Indeed,
that's alone is impossible.
the discussion and the self-reflection, that gives the advances.
That's true.
Indeed, yeah. Well, sorry to interrupt you. But, just looking at the watch, so we're close to the hour again. Okay. So our time is nearly off. Okay. So I want to thank you very much indeed. It was absolutely fascinating and a lovely insight into the current research you do at the moment. And I want to ask Gerald if there were any questions from people who followed us.
Yeah, sure. We got some questions. Some of the questions were already answered during your discussion. So I just picked the ones I think which are not answered already.
Yeah, no.
So is the cat head based on an original archaeological find?
Yeah.
So,
I worked during 4 or 5 years in the Brussels Art Museum history, and the head come from there. Of course, it's not a print. I don't like to create false things. So of course, it's an imitation, just to be sure that it's impossible to solve this one after, so like a false. But so like always time in my case, I would like to have something come from the site or come from the museum directly. I don't like to invent something new. Yeah.
Okay. Yeah. Thank you very much.
Yeah. Well, the cat was considered a holy animal. So it was the cat goddess Bastet. So the cat would be quite a usual object for veneration.
We take it just because it's more complicated than the Osiris. Osiris, you don't have any core inside. So when we understand something, we would like to go further. And so now we have the cat head. The next step is to create her whole statue. So that's the next step for next years.
Wow.
Okay, thank you. Yeah, the next question would be, how big are other originals? I think the viewer means what's what's the biggest size of such casting molds? Because on your pictures we can see that it's rather small renderings of casting molds.
Yeah.
Do you think there were really big ones with that technique?
Are there any technical limitations to the size?
Okay. For this moment, what we find is only small molds, complete. So like I say, it's Raffle, it's the unique in the world. Of course, when you go to the site, you find piece of mold, and some of them is more huge, of course. In Cantier, for example, is one of the best production that we know for this moment. We don't have so much site with metallurgy in Egypt. You need to know that. But in Cantier, the German find a lot of huge piece of mold. I know that they make analyze and then make studio about that. I don't remember the size, but that can be more than 1 meter or so like this.
Wow.
Wow.
Quite big. Well, I mean, the plate you showed us, well, that's quite big in its own right. So it's quite reasonable and likely that there are big molds for other objects as well.
And what is surprised is that at this moment, when you have a normal tools, is 8 or 10 grams, and the plate is 100 kilo. So that would like say that's for the first time in Nubia, we can propose a new technology first, new alloy and a new techniques. Is really something surprising, and is maybe, of course, is something exceptional. It's something that they don't do that every year on every day. It's impossible.
Of course, once for a temple,
yeah, it's one time they do that, and after this they close the site for this. We know that, but in any case, I think that's what is also important at the end is to come back to the archaeological field and see the impact of the technology for the society. It's impossible to say everything, but sometimes you have new clues, and you can say, okay, in this case, for example, they do something really new, a new job is something really exceptional. And where come from the alloy, where come from the material, where come from the copper and the bronze for this? And that's, we don't have the answer, of course, but that would like say that they have the possibility, the economic possibility to do that. That is interesting.
And to have kind of to collect this large amount of material.
Just this. So that's sometimes you can also ask question for the old site and for the old society, and to say, okay, go back to the reality, and we can ask the question, not answer, but just ask the question is a good thing also.
Okay, thank you.
Thank you.
So the next one, I'm not sure if it's well translated. I just say it. How big did the workplace had to be to create something like this, or was there an industry in ancient Egypt who was specialized to do this? How could a workplace look like? Do you have an imagination?
So in Egypt, we know more about the state than the private technology. For the private technology, we don't have it. Of course, you have a private technology. It's impossible that everything was made by the state. But for this moment, the most information that we have come from the state himself. So the answer is a temple. The temple is a place where, of course, you have religion, but it's also an economic place where you have the possibility to create the maximum of the stuff that they need. So like the bronze, the potter, so like each well, they have also the cavalry, they have also the army inside the temple in the New Kingdom. So of course, the most important industry is linked with the temple, the system. So is there sometimes, so like in the Middle Kingdom, you have new harbors, so like Ensona, Jarf, and that's the French excavation that they do for this moment. And we see that sometimes they have external production, but linked with the state also. For Ensona, you need to know that you have maybe 200 smelting furnaces there, 10 melting furnaces. So it's a very huge site also for the Middle Kingdom. In Cantia is is inside the Nile. It's close from the Nile. It's in Delta. But it's a temple system for the Ramessid period. So sometimes we have some point, and we know what's happened there. Amarna is a huge place. Buen also. So many temples at the end have an industry quartier belongs to the temple and the control of the temple of the state that depend from the times.
Probably just a question that just came to me. The workshops were there to meet the demands of the pilgrims who came there and produce these statues who are devoted to the temple. And what happened afterwards, after the rites? So were the shirts and the figurines gathered again and recast, or were they used for something else?
That depends for the period. We know that the copper is so rareful and so expensive that they pay a lot of attention of the material himself. So we know that the priests wait the tools before the work, after the work, just to be sure that they don't steal any fragment of copper. We know that.
Okay. Wow.
So that will I say that depends from the times. And in the Old and Middle Kingdom, it's sure that when you create a statue, they are under control from the state and the priest, and they are always inside the same system. And so you have a huge recycling
it's kind of a recycling process.
For the Middle Kingdom, for the New Kingdom, I think it's quite the same things. For the late period, it's quite different because there you have more bronze, and the lead bronze is there. Sometimes in excavation you find a mound of Osiris in the corner or in the temple, because it's a kind of devotion. So they put the small figure in the corner, and they're still there. That doesn't move. But always time you have a recycling system, and I think that for the most of the periods, the control of the state is so huge that it's quite complicated to do what you want to do if you are private.
Okay.
Well,
sounds familiar.
Normal, huh?
Sounds familiar.
Yeah, but in the case, for example, for Ensotna, if you know that you have 4,000 people in the desert, of course, it's so expensive to do that. You need the boat, you need the trees, you need the charcoal, you need so many things.
Yeah.
When you have a copper from 8 grams, it's not gold, but it's quite expensive. So you pay attention about that.
All right. Thank you.
Thank you.
Thank you. So the last question. It's directed to you, George. Which projects do you want to do next? Is there any big thing you want to do? Any favorite project?
I would like to continue the collaboration with Pierre Tallet and Claire Somaglio, because it's really interesting and really exciting. And so, like I say, we start with KERMA, and we would like absolutely know to understand the technology that we have in Sudan. And it's really nice because Johannes Hannemüller is also in Sudan, and we can continue the collaboration there. So yeah, I think that's we would like absolutely to go to the mines, see what happened there, see the maximum of technology as possible. Well, just continue archaeology. That's a dream, and it's really nice.
So maybe we will hear more news from you.
Yeah,
the next year maybe.
Yeah, very curious to see,
just curiosity.
The article. Yeah.
Yeah, I think it's one of the things that when you are an archaeologist, you are curious and would like to see. So it's only this. Yeah.
Sure. Okay.
Yeah, I think that's it. That was the last question.
Okay. So, I would like absolutely to thank my old colleagues. If I forgot someone, I'm really sorry. And I would like to thank you because it's really nice, and thanks a lot for the job and for the exhibition that you do. Thanks a lot.
I want to thank you for your contribution together with your colleagues, of course, and for this really lovely talk. It was absolutely interesting and really something new for me. And I wish you all the best for your future works. And I do hope we'll meet again, and probably in live, not only via internet.
Yeah.
And probably we'll have another joint experiments or something. So it would be absolutely fascinating to see this in live, real, and we'll keep in contact.
We do. Thanks a lot.
Yeah. So,
and the best for you also. All the best.
Okay. Thanks. Thank you very much. Bye-bye.
Bye.
Thank you. Bye.
Bye.